Okay, let's get into it. If you've ever been in a huge venue, like a stadium or a casino, and wondered how all those screens work so perfectly.
Yeah, how it all just runs without a hitch.
Exactly. Well, you're looking at some seriously complex tech. Today, we're diving into a key part of that engine room, the WolfPack 4K30 HD base input card.
Right, and specifically its role in those big modular matrix switchers, the 9 by 9s, 18 by 18s, all the way up to the massive 36 by 36 systems.
Our mission here is to really unpack how this one seemingly small card manages to distribute high-quality video over huge distances.
And not just that, but how it enables the kind of reliability and control that system integrators absolutely need.
So a key spec that jumps out right away is HDBaseT over a CT6 or ST7 cable. For anyone who isn't deep in AV infrastructure, what does that actually mean?
It's basically the ultimate simplification. I mean, you're running everything high-res video, control signals, sometimes even power over a single standard network cable.
And the specs on this card are pretty impressive.
They really are. It can push a 4K 30 signal up to 110 feet.
Okay, and for 1080p.
If you drop to 1080p, you can stretch that signal all the way out to 220 feet. It's also built for, really rich visual data. It supports 3D 48-bit deep color.
That's a ton of data. And whenever you're moving that much information, the absolute killer is always lag, latency.
It's the #1 issue.
So what separates this kind of professional gear from what you might have at home?
It all comes down to that latency. WolfPack's implementation of HDBaseT has, well, they call it virtually zero latency.
Virtually zero.
To give you an idea of how wild that is, over 330 feet of cable, the delay is less than 7 microseconds.
7 microseconds.
Yep. And if you're only running 100 feet, that drops to just 3 microseconds.
That's just an astonishingly small number. It's almost instantaneous.
Precisely, and that's the guarantee, as the sources point out. In places like an auditorium or a church, it means the speaker's lips are always, and I mean always, in perfect sync with the video.
No weird delay.
Never. And this stability also supports huge bandwidth, up to 10.2 Gbps, and all the audio formats the pros need. 7.1, Dolby Digital, True HD, DTS HD, you name it.
So that speed and stability, that has to be backed by some serious engineering. Which brings me to the physical design. These are one-port slide-in cards.
Right, for a modular system.
Why is that modular approach so important from a business or maintenance perspective?
It's all about total cost of ownership. Think about it. If one signal path fails in a giant 36 by 36 matrix,
You don't want to replace the whole thing.
of course not. That's a nightmare. Huge cost, massive downtime. With this, you just find the one faulty card and swap it out.
So maintenance becomes surgical, localized.
Exactly. It makes the whole system dramatically more reliable in the long run.
Okay, so with these huge systems, control has to be a major factor. How do integrators actually manage all those inputs and outputs?
You've got a ton of flexibility. There are the front panel buttons, of course, standard RS-232, but there's also a web GUI and even dedicated iOS and Android apps.
And what about fitting it into an existing ecosystem?
That's the other key part. These are designed to play nice with all the major control systems. AMX, Control4, Crestron, Savant. It integrates right in.
Now, here's something that I thought was a real aha moment for any custom programmer out there. The source mentions a really simple RS-232 command structure.
Oh, yeah, this is huge.
Why is that so important?
Because writing custom drivers takes time, and complex code is a pain. When the command is simple, like, the example they give is you want to switch input 8 to, say, outputs 1, 8, and 16.
Okay.
The command is just 8 by 1 and 8 and 16, and then a period. That's it. It just cuts development time way down. It's built for speed.
Shifting gears a bit to quality assurance, how do they make sure these cards are reliable before they even leave the factory?
Every single product goes through a multi-step test, but the big one is a mandatory 24-hour aging process.
A 24-hour stress test.
Basically, they stick it in a standard aging room and just run it hard for a full day. They try to break it before you get it.
And that confidence is backed up by the warranty, I assume.
Absolutely. They have a 2-year WolfPack Care Advance Replace warranty.
What does that mean in practice?
It means if a part fails and support verifies it, they don't wait around. They send a new replacement unit out, usually within 24 hours in the US. They prioritize keeping your system online.
That focus on continuity is critical for these kinds of installations.
Sure.
And one last quick tip from the source. The card has an HDMI Loopout. Why is that little port so useful?
Oh, it's a lifesaver for installers. It lets you plug in a local monitor right at the source to check the signal, and it helps manage the ED handshake.
The what?
ED. It's just the negotiation between your source and the display to figure out the best video settings. Having that local control just solves so many headaches on site.
So when you put it all together,
Mhm.
what's the big takeaway for you?
The value proposition is just crystal clear. You get extreme reliability, that virtually zero latency for perfect AV sync, and just incredible integration flexibility.
It's powerful, it's professional, and it's actually designed for the people who have to install and maintain it.
Right. And what's fascinating to me is the sheer range of places these are used. The sources mention everything from sports bars and casinos to
Like,
nail salons and churches.
that's a huge range.
It really is. It raises this question of how one piece of uniform high-end AV gear can so effectively serve all these completely different environments.
And to me, the final thought is this. The fact that this tech guarantees sync down to the microsecond.
Hmm.
It suggests a future where things like synchronous remote performance musicians playing together from across the globe with no noticeable delay might not be science fiction for much longer.